There are different types of quadrilaterals, and I've got them classified on the screen. Let's have a look. We've got, first of all, a trapezium. That's got two sides parallel. So if the two sides parallel, it's a trapezium. A parallelogram, on the other hand, has two pairs of sides parallel. See, that one is parallel to that, and the sides there are parallel. One property would be that the diagonals bisect each other in a parallelogram. You can prove that using congruent triangles. The third type is a rectangle. We can call a rectangle an equiangular parallelogram. It's got the same angles. There you got it, all 90 degrees. And the diagonals again bisect each other. Now, a rhombus, special form of parallelogram, it's an equilateral parallelogram. It's got the same sides, not the same angles, the same sides. See, there we've got a rhombus. Finally, we get to a square, which can be described as an equilateral rectangle. There we've got it. Or an equiangular or equilateral rhombus. Another definition would be an equilateral, an equiangular parallelogram. Yeah, fancy terms, I know, but they are used, those terms. Now, how are the square, the rectangle, the parallelogram, etc. related? A lot of mistakes are made with that. I've actually got quite a nice diagram here, and I'm pretty proud of the way that is constructed. We've got a quadrilateral, any four-sided polygon. That can become a trapezium if you make two sides parallel. It can become a parallelogram if you make two pairs of sides parallel. And now you have to split them up. You split them up into a rectangle and into a rhombus. So a rhombus is not a rectangle. Yeah, they're completely different things. They're both parallelograms, but they're not, one is not the other. Once you then make special conditions again, you get back to what's called a square. So there you've got the diagram, the classification of quadrilaterals. There's only time in this program to do one quadrilateral problem. You should try some from your book. Here we've got a typical problem. Find the perimeter and area of this parallelogram. Well, the perimeter is easily found because that's just 60 plus 45, two lots of that. And that becomes 2 times 105, 210. For the area, we use a little trick. We can transfer this part to that part over there, as I've done in the diagram. And then you create a rectangle, which is 30 meters by 60 meters. And of course, the area of that is 1800 square meters.